Good afternoon, gentlemen, and welcome back to part 3 of our video on a sodium formate reduction. Now, the last time you seen me, I was fixing to add these chemicals to the water to dissolve them. On the right hand side, we have our saturated sodium formate solution. On the left hand side, we have our 30% sodium hydroxide solution. Now, something I want to point out here is in the sodium hydroxide solution, we dissolved almost a half a pound of sodium hydroxide into this solution. But if you'll notice, the water level really didn't rise that much. It's probably about 825 milliliters. Now, we had almost 1 3/4 pounds of sodium formate that we dissolved into the water over here. Now remember, we originally started with 800 milliliters of water and we added the sodium formate to it, and now we have 1200 milliliters as our finished product. So that 1 3/4 dissolved and raised that solution about 400 milliliters, or by about 50%. Now, on the sodium hydroxide that I dissolved, it was clear. I turned the burner off and I let it cool down, and some type of flocculent formed in there, and it's black. It looks almost like dryer lint. Now, usually this comes out clear. I'm not sure if it's the sodium hydroxide that caused that or the particular piece of stainless that I used, but usually it's clear. But it doesn't matter, because we're going to add it to our trashy solution of silver nitrate to drop some hydroxides out. So if there's some trash in that, we're good. It's like when I make my stainless chloride up for gold testing. I'll put a piece of solder in the bottom of it, and that solder will have a certain percentage of antimony in it. Well, that'll be inside my testing solution, but it really doesn't interfere. This black lint looking stuff really shouldn't interfere, because after we drop the hydroxides out of our solution, we're going to filter anyway. Now what I'm going to do is I'm going to take this sodium hydroxide solution and I'm going to pour it into one of these 2-liter Mountain Dew bottles back here with a lid on it. And as I need some periodically, I could pour it into a smaller container or a smaller beaker. But I'm just going to add that directly into the bottle, because the trash really isn't going to affect the process. Now, over here on the right where I dissolved the sodium formate, I have some particulate in there also. And that is a red particulate, like cayenne pepper. Now, I'm not quite sure what that is, but here in a moment we're going to adjust the pH balance of this solution to about 4 using formic acid, and then we're going to filter this solution. Now, you cannot filter this sodium hydroxide through a regular paper filter or cotton. Remember, this stuff destroys organics. If you try to filter this with a regular filter paper, it's going to eat it up just like sulfuric acid would. So you would have to have some fiberglass filter papers to filter this with. Unfortunately, I don't use those very often, so I don't have any on hand. But like I said, this trash is really not going to affect it anyway. When we filter our silver nitrate solution to get the hydroxides out, this trash will become trapped in the filter paper also. Now over here in a moment, what we're going to do is we're going to adjust the pH of this with some formic acid. We need this down to a 4 pH. Now I have my pH meter sitting here in the back, so let's just go ahead and turn this on. And we're going to see what the pH of the sodium formate is right now. Now, it didn't take long for either one of these to dissolve in this water. I probably heated both of them for a period of about 15 minutes and turned it off, and they were both dissolved just fine. Okay, 127.9. We're showing about 128 degrees at a pH of 8.2. We need to get that pH down to a pH of 4. So we're going to adjust that with our formic acid here in just a little bit. I only have two hands. One's holding the pH meter, one's holding the camera. So what I'm going to do is I'm going to cut away here in a minute and go ahead and get me some formic acid ready, and then we're going to adjust the pH of this sodium formate solution. Now, back over here behind me in my other fume hood, I have dual fume hoods. I can turn around from one station to another. Right here we have our silver nitrate solution that we had earlier. I've already transferred this into a 2,000 milliliter beaker. But the reason I wanted to show you this is I have a little experiment set up here. We're going to have to figure out when our silver is out of solution and we can quit adding sodium formate to it. So we're not just adding sodium formate and we're wasting it. Plus we need to know when all of our silver is out. So what I have here is I have a pipette inside of this solution, and over here on the right hand side I have a small beaker with some water in it, and it's against the piece of brown cardboard so you can see the experiment in a minute. But what that is that's water with about 2 grams of salt thrown in the bottom of it. And if you look real good, there's still actually salt in the bottom of it. Now, what I'm going to do is I'm going to take a sample of this solution of the silver nitrate with this pipette, and I'm going to add just a drop to that water right there. And that water is salty right now. So what we plan on doing is forming silver chlorides. And after a while you've done this, you can tell by the reaction and how thick the chlorides are and the concentrations about how much silver you have left in the solution. But as long as you're forming any kind of chlorides, you still got silver in your solution and still need to add some sodium formate to it to reduce the rest of the silver. So what I'm going to do is I'm going to go ahead and get a sample of this now. And then I'm going to come over here, and what we're going to do is we're going to add a drop or two. And if you'll look, let's add a little bit down in there. Now if you'll look, what we've done is we've created silver chlorides. And this will help you determine whether or not you still have silver in your solution. It's just a white cottage cheese. And once you've done this a couple of times, you'll get used to it and you'll know what to be looking for. But it's just a white cottage cheese looking substance. Looks exactly like cottage cheese. The stronger the solution is, the more it'll look like cottage cheese. So now what I'm going to do is I'm going to go ahead and cut away here for a minute, and I'm going to come back, and I'm going to go ahead and add this sodium hydroxide to a bottle back here. I've got me a ceramic cores filter that I'm going to use for that. And then after I add that to my container, I'm going to come over here and we're going to adjust the pH of this with formic acid and get ready to reduce some of our silver from our silver nitrate solution. So I'll see you gentlemen in just a moment. Okay gentlemen, we're back and we have our sodium hydroxide poured up in our bottle in the back. I have my pH meter. We have our saturated sodium formate solution. Over to my left, I have my bottle of formic acid. And to the left of it, I have a small beaker filled with 150 milliliters. Now, how much are we going to use? Well, that's what our pH meter is going to tell us. I'm not exactly sure because I've never done this before, and I'm sure the larger the solution, the more formic acid we're going to have to add to balance it. So, let's go ahead and turn our pH meter on here. And y'all will have to excuse me, I'm doing this one-handed today. But we're going to get our pH meter turned on. And we're going to check and see where we're at again. And as you can see, we've cooled off a little bit. About 120 degrees, I guess. The pH is still about 8.2. So what I'm going to do is I'm going to take this out, set it back over here in my water, and we're going to have a little bit of fun with the formic acid here and see how this is going to work. I'm not adding much. Maybe about 25 milliliters to it, and we'll take our pH probe and we'll kind of move that around a little bit, stir it up, and believe it or not, our pH has dropped a pretty good bit. We're at about 5.3. Now, I don't want to overshoot this. Let's take our glass stirring rod and let's make sure we've got a good homogeneous mixture in this beaker here. Stir it good. Alrighty. And we'll get our pH meter again. And we'll come over here and we'll take a look. And I've just got the probe below the surface there. We're still at about 5.3 and we need to be at 4. So it didn't take much. I only had to add 25 milliliters to this solution. So this stuff should go a long way. Let's we're not going to try milliliters. We're just going to try a few drops and look at it with our eye here and use our pH meter. I probably added another 5 milliliters. Alright. Let's see where we're at on our pH. We're at 5.2. It's dropped a little more. Alright, so that tells me we need to add increasingly. So I guess about another 10 milliliters here. And let's see where that gets us to. Now, after we finish adjusting our pH, we'll be able to filter this and put it to the side for our final reduction. Alrighty. Let's see where we're at. We're at 5.1. Okay. We've still got one more to go. So let's add another 10 or 15 milliliters. Let's go about 25, I guess. You got to be careful not to overdo these things. You have a tendency to always want to add more, but sometimes hold that tendency back. It's not a good thing. Oh. Alrighty. Let's try our pH meter one more time over here. Okay, 4.9. It seems it didn't take much formic acid in the beginning to drop that pH down, but we've still got to hit that 4 mark. So, I'm going to add about 25 milliliters here and see what we get. Alrighty, let's stir that again, get us a homogeneous mixture. And our pH meter again. Yep. Alright, we're at 4.8. It's going to take more. So I'm going to spike the rest of this in there. See how that works. That's 150 milliliters. Alrighty. Let's come back to our pH meter again. We've dropped to 4.6. So, let's pour us up another 150 milliliters. See if it's going to take all that. Alrighty, let's add about 25 more milliliters. About 25. And stir it up so we get a representative sample of our solution. I've noticed that the solutions turn kind of cloudy while I'm doing this. Okay, let's give this meter time to adjust for a minute here. Alright, 4.5. Alrighty. Let's try about 50 milliliters and see where that gets us then. Alright. And our solution is growing in size because we've added almost 300 milliliters of formic acid to it. Okay. Let's go over here and see what our meter says now. .4. Alrighty then. Boy, it seems that first little bit's easy to drop, but then that last little bit requires a lot of formic acid. We'll add all that. That's 300 milliliters of formic acid to that 800 milliliter saturated solution. We're trying to get this pH down to 4. Let's see where we're at. We're getting close, I think. We're 4.3. Alright. Let's pour us up another 150 milliliters over here. That'll be 450 milliliters if we use all of it. So I'm going to add probably 50 of this and see where that gets us. The solution's starting to clear up just a little bit. It's not as cloudy as it was, I've noticed. Or maybe it's just that the particles have started to flocculate. I can't tell it. We're getting close. 4-1. Oh! My meter went off on me. Now, why would you do that? It's got an automatic cutoff, which is a good thing for saving batteries. Can't blame technology, I guess. Okay. We're still right around the 4-2 mark. And let's go with another 50 then. Alrighty. Let's stir this good. And let's see where we're at. We are very close. So let's go ahead and add that other 50. So that's 450 milliliters we've added. That should get us right about on it, I hope. Hey, what do you know? We're right at 4. So it took 450 milliliters of formic acid to adjust that pH from a little above 8 to 4. And we originally started with an 800 milliliter saturated solution of sodium formate. So this is where we want to be at a pH of 4. And now we're going to filter this solution. And if you'll look, you'll notice that it's got some clarity to it, but it's got some bubbles or some flocculant or something. I'm not sure what it is, but as we drop that pH from 8 down to 4, it appears that that solution unclouded anyway. I'm not quite sure what to make of that yet. But we have our saturated sodium formate solution reduced to a pH of 4. It took 450 milliliters of formic acid to adjust that 800 milliliter saturated solution. So I'm going to cut away now, and we're going to go over here and we're going to filter our sodium formate and get it ready to add to our silver nitrate to precipitate some silver.